Hi everyone, myself Nithin Heraje, Assistant Professor, Department of Computer Science and Engineering, AJ Institute of Engineering and Technology, Mangaluru.
In this video, I will be discussing lab program 9 of Computer Graphics Laboratory, that is to develop a menu driven program to fill the polygon using scanline algorithm. So just look at this diagram. I will tell you what is scanline algorithm, how it works. Okay, so see these lines what you are weaving over here, these we call it as scan lines. Okay, and this is y axis, whereas this would be the x axis. All right, so to draw this polygon, first we are going to draw a polygon by getting the four points like this. Okay, and then draw a polygon. After drawing this, actually we are going to draw this using you know lines. Okay, then with that we are going to fill this polygon. Okay, that is using scanline algorithm. So how the scanline algorithm works is, so let's start with this point. So in the scan line we increment every y value by 1 unit. That is, if this is y value, so this would be y plus 1, y plus 2, y plus 3 and so on. With that we will find the value of x. So at this point, what is the value of x? So from here up to this point, what is the value of x? Okay, so this would be the left edge. So this is the left edge of the polygon, and this is the right edge of the polygon. So we will have the value of x at this particular point and the value of x at this particular point. So once we find the x value, that is you know how to find the slope of this line, after which you can find the value of x at this particular point. So once you find this point and this point, so what we are going to do is we'll just draw a pixel for every interval up to this x point. Okay, so this we are going to do everywhere, and finally your polygon, this polygon will be filled with some color. Okay, so this is about the scanline algorithm, how it works. So let's discuss the logic behind this. So first let me go to the main program. So this is the main program. So we know all these things. Then my init function to initiate the things, and we'll see what happens in a display function. So here you're going to create a menu. Okay, and that menu has two options, that is fill the polygon, or you have another option is empty polygon. So here you give the ID as 1 to fill the polygon, and this as 2 for empty polygon. And when you right click on the mouse, you will have the menu attached in the output screen. So this is for that. So attach menu when the right mouse button is clicked. In the display function here, you can see we are giving the value of x1, y1, x2, y2, x3, y3, x4, y4. So that those are the values for these points that has been given. After which we are using a line loop. Okay, so using the line loop, we are going to construct a rhombus like this. Okay, uh, and then we will check if the flag fill flag is equal to 1. Okay, So fill flag, in the sense, you can just look at this in the fill menu option. When the fill menu is called, when you click on option 1, the flag is set to 1, and if you click on option 2, the flag is set to 2. So if the flag is set to 1, that means you need to fill the polygon. If the flag is set to 2, you'll have to um, keep the polygon empty. Okay, then you call the display function. So in the display function, we are going to draw the polygon, and if flag is equal to 1, then you call a scan fill function by passing all the 4 vertices. Okay, so we'll see what happens in scan fill function. So this is the scan fill function. So here you are initiating an left edge array with 500 and right edge array of 500. Okay, and why this left and right edge is that? So the value of x, that is of the left edge, that is this and this. The value of x for different y values will be stored in the left edge, and the value of x for these right edges will be stored in the right edge array. Okay, so that's why we have left edge and right edge. So this here, this is to initialize all the values of left edge to 500. That means you're going to set it at the right end, and all the value of right edge you are initializing it with the value of 0. That means you will set the right edge at this particular point. Okay, so that means you're going to initialize the left edge in the rightmost point and the right edge in the leftmost point. So after that, you're going to call a edge detect function. So for the edge detect function, you are going to pass x1, y1, x2, y2 value, that is one edge. Okay, so this edge you are going to pass first, and along with that you have passing the left edge and right edge array. And again you'll have to call edge detect function for this edge, that is x2, y2, x3, y3, and then again you call that same function for this edge, that is x3, y3 and x4, y4, and again you will have to call one more edge detect function, that is for x4, y4 and x1, y1. Okay, so we'll see what happens in the edge detect function. So we'll go to edge detect function. So this is the edge detect function with the 2 vertices. This holds the 2 vertices, and this is an pointer array. Okay, now here we'll have mx, which where we find the value of slope. Okay, and there is a x variable for a temporary storage of x value, and this is a temp variable. We'll see why it is. So if y2 minus y1 is less than 0, then you'll have to just swap the things. That is, always y2 should be greater than y1. Okay, so if at all y2 minus y1 is less than 0, then swap y2 y1, and also along with that x2 and x1. Okay, so there won't be any problem for this. But if you look at this 2 edges, here y3 is greater than y4, so you'll have to swap these two. Similarly, y4 will be greater than y1, so you'll have to swap these two, because this acts like y2, x2, y2. This is the first point, so it acts like x1, y1. This is the second point, which acts like x2 y2. So here the condition where y4 is greater than y1, that means y1 is greater than, that is the first point is greater than the second point. So you'll have to change this, and y1 value has to be swapped with y2, x1 value has to be swapped with x2. So once after that is done, next we are going to check if y2 minus y1 is it not equal to 0. Okay, so let me take an example. So here x1 y1 is 200 comma 200, x2 y2 is 100 comma 300. Okay, so the value of y1 is 200, value of y2 is 300. Okay, so 300 minus 200, is it less than 0? No, so it will not execute. Next, it checks this condition, y2 minus y1, that is 300 minus 200, is it not equal to 0? Yes, it is not equal to 0. So mx equal to, here as we told, x2 value is it is 100 and x1 value is 200. So 100 minus 200, it would be minus 100, divided by y2 minus y1, that is 300 minus 200, again 100. So minus 100 by 100, it gives you minus 1. So the value of mx will be minus 1. Okay, so this condition is when y2 is equal to y1. Okay, so then you'll have to initiate mx equal to x2 minus x1 when y2 is equal to y1. Okay, then temporarily store the value of x1 and x. Okay, then we'll start with the for loop for I equal to y1 up to y2. Okay, so I holds the value of y, and LE of I or RE of I will hold the value of x. So I will give me the value of y, and the arrays left edge and right edge will give the value of x. So we get x and y value, then after which we can plot the pixels. Okay, so look at this, I equal to y1, which is 200, I less than equal to y2, which is 300. Okay, so here it is 200 to 300, that is from bottom to the top. Okay, so you'll get this condition when you're going from top to bottom, that is from x3 to x4 y4, and from x4 to x1 or y4 to y1, that is from top to bottom. This condition will be satisfied, then you'll have to interchange. Okay, so here y1 value is 200, y2 value is 300. So if x is less than LE of I, LE of I, where we have initiated with the 500. So all these values are initiated with 500, and all the value of RE is initiated with 0. So the value of x is x1, nothing but it is 200. So x would be 200. So 200, is it less than 500? Yes, 200 is less than 500. Then initiate reinitialize the value of LE of I, that is LE of 200, that is this particular point, LE of 200 is equal to 200. So this point you will get it as 200, I value is also 200, LE of I is also 200. So y value is 200 and x value is 200. Next, check one more condition. If x is it greater than re of I? Yes, x is 200 and re of I is 0 initialized. So re-initialize re of I equal to int x, that is you initialize the right edge to that's to 200, and this you increment the value of x by the slope, that is mx. What we have found is mx. Okay, so you'll find the next value of x. So x is 200 and mx is -1. So the next value of x would be 199. So somewhere here you will have 199. X value is 199 now, and you continue this for loop again. Okay, start with the for loop. So y value will be 199. This remains 300. Okay, and again it starts. So how it initializes is LE of 200 equal to 200, so on up to it takes you up to this y2 value, which is 300, where your x value stored would be 100, that is at this point. Okay, at this point LE of 300, that is the 300 is the y value, would be equal to x2 value, which is nothing but 100 over here. Okay, so until this point your left edge value and right edge value will be same. Got it? So after you pass this point, that is x3 y3, left edge value remains the same and this right edge value keeps changing, and it gets you these values. Okay, you will get these values in the right edge. So left edge you will have all the values of this x and y, you will get. Right edge you will get this x and y. So go back to the function. So all your edges are detected. Now you have this function for y equal to 0, y less than 500, y plus plus, that is you will start from 0th point to 500 point. Okay, and where you draw the pixel for LE of y and RE of y. Okay, so which is nothing but you will get the value of x at that particular point. So there you will go to draw the pixel with I and y value. So if I take this line, so your left edge will give the value of x from this point and right edge will end at this point. Then you start incrementing the value. So one by one you are going to draw the pixel in this line and complete it. Next, go to the next y, increment the y value, and you will find the next x value also using the slope. Then you fill one by one up to the right edge. So this is how scanline is going to work. So draw pixel I comma y, just you are going to draw a point. Okay, in the draw pixel you are just going to draw a point with the R and G being the color, which gives you yellow. Okay, so this is all about scanline fill algorithm. It's very easy if you understand. Please do not mug up the logic. If you just come to know the logic, you can just handle it easily. All right, hope you understood this program, right? If you look at this output, you can see that initially a line would be drawn like this, a line loop is drawn like this, after which you find that these pixels has been drawn. So these are the yellow pixels that has been drawn from this point to this point, and similarly it has completed everything. So this would be the left edge and this would be the right edge. Okay, so this is the output, and you can see that when you right click you will have two options, fill polygon and empty polygon. If you give fill polygon, this will be filled with yellow color, or else it remains blank just with the line loop. Got it?
Thanks for watching this video. If you like, please click on the like button. Thank you so much. Thanks for watching.